All right, hey everyone, welcome to week 41 of Chill Kernel Hacking for Fun. This week we are continuing with Lab 4, like we have been for a long time now. And we're going to continue with exercise 7, which is implementing various system calls for environment creation. Give me 1 second. I need to actually post this in the Discord really quick. But yeah, environment creation. So we're not doing exactly the same kind of like fork system call as is present on Linux and everything else, but we'll be doing kind of a variant of that. Okay. All right, Discord ping is sent out. Nice, yeah. So last time we started and got a bunch of work on this done. Let's just check the Git history really quickly, see what's going on. So we're here on the Lab 4 branch, and I've already done a bit of work. I implemented sys exo fork last time, also sys end set status. And now we're going to be doing, I think, yeah, page alloc is what we were working on last time. I'm also going to check if the chat widget is working today. Yep. Right, so last time I was working on page alloc, and I kind of spent a lot of time on this input validation stuff, which actually I kind of cringe to look back on because I was totally doing it wrong last time. I was doing it super inefficiently, and it was just the wrong way to do it. So now, in the meantime, I quickly searched about a better way to do the bit masking thing. So I'm just going to come back here and build. Hopefully that builds. Good. So that is building. Hey Shovik, what's up? Nice to have you back. Cool. So it looks like the chat widget is working. Nice. All right, well, let's get back into this. So I am going to delete all this stuff. And let's come back, or like, I guess we're mainly interested in just this function. So what are we doing again? Sys page alloc. Allocate a page of memory and map it at virtual address with permission perm in the address space of env ID. Page's contents are set to 0. If a page is already mapped at VA, that page is unmapped as a side effect. So it's like overwrites any existing pages that might be there. Minecraft and OS1. Yep, that's the goal. Definitely the goal is to run Minecraft. Yeah, we'll probably be able to get that done pretty quickly. I think that's maybe not next week, or maybe the week after. We'll have Minecraft running. Right, so perm is in a particular has these particular requirements. U or P must be set. Avail or PTEW may or may not be set, but no other bits may be set. C PTE syscall. I just got a warning saying my stream's bitrate is lower than recommended. I wonder if there's something I should do about that. Quick check of the stream settings. $6,800 K. All right, I'm gonna make this number bigger. Hopefully that's okay. Okay, well, let me know if the stream quality is not good. Right. Okay. So yeah, back to this. This page alloc, so I was doing my error. This function is a wrapper around page alloc, page insert. Most of the new code should be to check the parameters for correctness. If page insert fails, remember to free the page you allocated. Yeah, I can already tell. I feel an immediate urge to try to write some unit tests up front, actually, for this. But maybe it's just enough to start writing down some of these error conditions. Yo, sub, what's up? So, because there's a bunch of different inputs. Happy path, valid env ID, VA, perm, error paths, bad env ID, edge cases. VA is already mapped. We need to unmap existing page. Is it possible to have a bad virtual address? Bad permissions? Right. So it already gives us a bunch of hints about what to do here. Page's contents are set to 0. That's mostly it. Okay, starting off. So first thing to do, checking the VA. If it's greater than or equal to utop or is not page aligned, we error out. If VA is greater than or equal to utop or it's not page aligned, go to enval. Then we're checking perm, and I was trying to kind of break this up a little bit. So there's two things we wanted to test. The first thing, does perm have these two required bits? And that's this condition. So this is like, are the mandatory bits set, which is if perm and the U bit and perm and P bit. So that's the first part of the condition. The second part of the condition is, does it have any other bits that are not allowed? And yeah, the more I think about this, the more unit tests make sense, maybe. It's just a little bit tricky because I don't have a great way to do unit tests. I would kind of need to figure that out. Currently, there are some unit tests that are just compiled to kind of just like run during the init process of the kernel, which is a strategy. You know what? Yeah, I think I would feel a little bit more comfortable with at least some kind of unit testing. Let's let's just see how I might do that. So a second. So right now, so I have all these random check functions, and I suppose that is as good a place as any. However, so where would I write these unit tests? I could write them directly in this file. And then export it into the syscall.h header. Do I include syscall.h? I do not. So that would be a bit unfortunate to include syscall.h just to access this testing function. But I don't know, maybe I'll do something else that might be kind of weird. I could create a separate a separate file called like tests.c and just run that from here. And then that way it doesn't pollute this production code with all these kind of random includes. That might, okay, I'm just going to give that a shot because I think that might be worth investing into anyway as just a bit of a better way to write unit tests. So, so what do I do? I'm going to just duplicate this file and call this tests.c. And I basically just want to delete everything. Yeah, I guess maybe not assert. I'm just going to comment them out for the moment. So this is going to be called tests.c, and it's going to have a function called I don't know, void run tests. And I suppose there needs to be, oops, wow. I suppose there needs, my base, yo, what's up, Tatia? My base friend, prepare a Discord. Your YouTube channel, Discord is our Discord page. I have to be honest, I don't have any idea what you're saying. Sorry about that. So I'm going to copy this header file and call it tests.h. And I don't know, I'm going to also delete everything once. And so now we're going to take this, run tests, and I suppose we're going to need something tests.h, if that works, or kern, I guess it's kern. And then over here we can call run tests, and we just need to include kern dot tests dot h. And then now we need to modify the make file. Do we need to do anything for the header files? I don't think so. So now I'm just going to do... So I think I need a couple things. Let's say I wanted to do an assert false, which is always a good test. Does this compile? And this should not run. This should assert. Good. So now what if I wanted to print something? Which are the common things you might want to do? This is not going to compile. Oh, oops. Cprint f. That actually did work, even though I didn't include. Where is cprintf declared? printf.h? No. console.h? cprintf. Something. Okay, what? Or maybe there's no space? Oh, there's what? I guess it's an int, so maybe I want this I guess it's stdio.h. So I'm going to include stdio.h. Okay, so we got our hello. So now we can do a very basic minimum amount. Yeah, we have a very basic set of stuff. I don't think we'll need like any of this. Monitor.h. The kernel monitor. Okay, so now we have our basic tests. Which is kind of cool. And what I think I'm just going to... Okay, I'm just going to do a temporary commit. And I'm going to make this a commit. It's just adding, but I don't necessarily want to commit this. Tests running. Finished. Okay, this is closer to what I want. Okay, good. So this color scheme is so... I need to do something about this. It's impossible to read these diffs. Okay, looks like the stream connection is excellent again, so hopefully it's working. Okay, so this is impossible to read, but roughly I'm just adding the basic of this. Oh yeah, the assert is still there. Because I need to do this. So now tests, test.h, run tests, and basic thing. Okay. Add infra for unit tests. Good. And So the next thing I could technically do is I could so basically I want to have a function that's like bool check perms has valid perms, right? In perm, and I want to take all of this and put it into a function so we can unit test it and pass in a bunch of different inputs. So return false, return true, something like this. I mean, this is kind of a dumb way of doing it. I should probably just do like return mandatory bits are set and not has disallowed bits, for example. That's probably a bit of a better way to do this. And then I want to have a test function. So this is going to be a static bool. And then I want to have a test function that's something like test has valid perms. Just quick compile check. Oh, that compiles good. So now I'm going to call test valid perms, and I just want to do some basic stuff. Like I want to, okay, if I was doing this really for real, I guess I would have a separate file. It's maybe called test syscall or something like that. Yeah, I'm not going to worry about that for the moment. So it's going to be something like has valid perms equals true, and 0. Actually, that's going to be false. So what are the test cases? Pass in 0, false, pass UP, pass the minimum, which is the U and P, and nothing else. True. Pass minimum and allowed extra, minimum and disallowed extra. For example, okay. Let's go to this comment. Maybe I can just pull this up over here to have it more readable. So avail W something else. Okay, so this is here. True. 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 That's also going to be true, right? Any of those options, and then this, then I just need to find something else random, like PWT. And yeah, I'm just gonna put in a 0 at 0 while we get this going. So, so those are some basic tests, right? 0 is false. This is the minimum. It has valid perms. Then the minimum plus some other stuff. And, you know, just for fun, we can remove one of these minimum things and make sure it's false, right? So this is not enough. And this is not enough. So I guess if we have this test, we technically we might not need this kind of test down here. You know, I mean, technically you can imagine some kind of bug where it passes these, but if PTE avail is present, it follows different rules. But I don't know, it doesn't, in this case, it doesn't really hurt too much. So now we have this function called test has valid perms. I want to go to syscall.h, and I'm just going to expose this thing. And then now over here in our tests.c, we can do something like test has valid perms. Does this build? Wow. Oh, okay, so right, I need a bunch of other stuff. Is it types.h? Where is types.h? Is it, oops. Types.h. Implicit test. What's it saying? Has valid. Oh, did I think I'm. It's like what's. I see. I cannot. Yeah, this is where we get into like kind of just annoying dependency things with like ordering or whatever. Okay. Okay, and now we're seeing tests running, assertion failed. So that's good. And so now we could do something like remove this and let's insert a fake bug into the production code. What's up, Ismail? Hey, I'm doing a little bit of unit testing, not because I really want to, but because I'm mostly working on this sys page alloc thing, but I just have this sense that the logic here is complex enough with the error handling that it's worth the peace of mind of having some unit tests to make sure I'm actually getting this correct. And yeah, so that's just why, because I have the suspicion that if I don't do the unit tests, I'm going to just like code a bunch of stuff, and I will probably have some bugs, I think, and I think it'll be much harder to debug them in this whole production syscall than otherwise, than in the nice isolated test, I guess, test bench or something. So So let's see. So I'm going to inject a bug into the production code, which is here. That just returns true all the time. And now we should see a few things fail. Okay, kernel panic on 186, right. That should be false. Okay, so now let's remove that bug. Let's inject another bug that that only checks if the mandatory bits are set. And so in this case, the test cases that are going to fail are the ones that add the extra disallowed bits. I think. And none of the tests failed. What? Oh, wait, what? Okay, so what if I change? Okay, what if I change this to true? Okay, that fails, right? Like it should. True, this should also fail. That also fails, good. Okay, so that was looking pretty right. Then I actually expect, okay, so what about this? So with the bug, all it's concerned about, right, is that, oh wait, this is a bug in the test. That should be false. Right, that should be false. So, no, like the disallowed ones should yield a false. So we'll do. I don't know, these like weird. These weird ones. So this is all just saying. Right, okay, then we'll do something like this. See, we're going to actually add both one of these extra ones. I'm actually wondering if I have a bug in the production code. I actually think I might. Oops. So the requirement is syscall.c. You can think about this slowly. So where is the comment? It's all the way up here. It's with this handling of these optional ones. I think I have a bug actually. I think they should maybe be in the bit mask, but I'm going to just let the tests expose that, I think. So, right, so the allowed ones are also valid, right? So, and the reason the bug hasn't kicked in yet is because the bug is in the second part of this condition, which is a bit too strict. We don't get there. And so as long as it has both of these things, it is going to pass. So all these tests, right? So good, either of the optional ones or both of them, that's all good. If it doesn't have the present one, that's false. And then time to test the disallowed ones. Okay, so from first glance, I'm just going to comment this out actually. This should all pass, I think. Okay, 200 failed. And that failed because that failed because it returned a true because we have this bug. Like our injected bug is there and it's only checking if the mandatory bits are set. They are set, and so it's going to pass. So now we need to fix our code to actually try to honor this disallowed bits requirement. So now I fixed it to the production code, and we should hopefully see a bit more progress. I think these should pass. So 189, what happened there? Okay, and that's right, and that's starting to fail now because of, I think, the bug that I was talking about. So I'm including too few things in the allowed bit mask. The allowed bit mask is actually PTU, PTEP, and all of these things. We have this bit mask of, let's say we had a 4-bit bit mask, and this one was allowed, and this one was allowed. What we're doing, and we have like an arbitrary input that we're being given, and then this is our bit mask that represents all of the bits that are allowed to be 1. What we do is we do a not of that, not bit mask allowed input, and then we AND that against the input, and that means any of the allowed bits are going to become 0 and then immediately cancel out that bit. But it's going to make all the disallowed bits 1, and therefore if there are any 1s in the input, those will be preserved through the AND. And in this case, they'll go right through, and then we can check this end result if it's 0. Ideally, it's completely 0, because either it was a bit we don't care about, or there wasn't a bit set in the input. But if there's anything that's not 0 at the end, that means there's an invalid thing. And so actually the allowed bit mask is this. There might even be a better way, a more optimal logic, but that even combines this mandatory bits are set thing. But for me, this is kind of the simplest way to go. So now I'm going to run the tests again, and it should not fail on this early one anymore. And it also gets all the way through and passes everything. Very well explained. Thank you. Now let's enable this last bit, this last test, which I believe should pass. And that passes. Okay, so that's good. Now I have a bit more confidence in my implementation of this, and I'm going to move all these things above right here. Okay. I mean, yeah, I could technically create like a test file, which would allow me to move this outside of the production code, which would be kind of nice. And then I wouldn't need this weird forward declaration for this thing, because I want to keep this thing kind of close to the function where it's used. I don't know, I'm just going to, yeah. Test syscall. Okay, let's see. So here's how things are looking now. So so now I'm a bit more confident that this is correct. Conspool, I don't know. Const everywhere just for fun. Mandatory bits are set. Has disallowed bits. Return that mandatory bits are set and it does not have disallowed bits. Okay. Looking good. Passes the tests. Let's commit this. So I'm not ready to, or, well, yeah, I can commit this stuff. And actually, well, this is actually a bit of a cleanup. Maybe I won't do that here. This will be the commit. So we're going to implement a standalone function for doing the check. We're going to implement some tests for that function. We're going to expose that test function outside because that's the, like, all this stuff is kind of private. Otherwise, we're going to expose this so it can be used in the tests.c translation unit. And we're going to do the include. Okay. Yeah. So, I'm just thinking, like, eventually maybe all of this could actually just be squashed into the commit that implements the system call ultimately. I'm not sure yet. I'm just going to do an intro. Yeah, well, we can see about that later. I'm just going to do a commit that says like test add has valid perms and tests for it. Okay, so then over here there's actually this thing which actually needs to go into the infra part, so I will amend that. And now we can continue a little bit more confidently. And it's also nice that we kind of have a place for tests now. That's like kind of cool. Okay, so over here, so now we just do if not has valid perms, go to inval, and we delete all this stuff. Perm, it's just called perm. Okay, that's a bit nicer. And just checking, actually, yeah, e-inval if the perm is inappropriate. Okay, let's move on. So our VA is validated, our perms are validated. Now what? Allocate a page of memory. So we're going to do a page alloc, right? It's even giving us a hint. There's a wraparound page alloc and page insert from pmap.c. So let's do page alloc. And the page's contents are set to 0, so we're going to set alloc 0. And what does this thing return even? A struct page info. Page info. Okay. And we, of course, need to check the return code. Return null if out of free memory. So if not page info, then return e no mem. I mean, technically I don't really need to have these go-tos, but I just thought it might be clean to not repeat that. I could just inline it. Okay. If there's no memory, to allocate the new page, or to allocate any necessary page tables. Because that's the next part. We're going to do the page alloc. And we need to also convert the env ID. How does this work again? You pass in the env ID, you get a pointer to the env, and this check perm. If check perm's at the specified environment must be either the current environment or an immediate child. Did I implement this? I don't think I did. This came with the OS, right? Check that the calling environment has a legitimate permission to manipulate the specified environment. And in this case, what's going on? So to manipulate the specified environment, right? So users, we're allowing user space to pass in an env ID. So it's pretty important we make sure that user space is not randomly allocating memory in other processes without permission. So I would say yes. Let's take a look at that again. The specified environment must be either ourselves or an immediate child. Apparently we're allowed to allocate memory in the immediate child, which I think is like on Linux. I don't believe you can just do that, but maybe that makes sense for us because we are doing things a bit differently with the design of the OS, and we're not really implementing a fully featured fork system call. We're actually implementing a bunch of low-level system calls that can be used to implement a fork in user space for some reason. And so maybe it makes sense in that case, as far as implementing fork in user space, that a parent should be able to allocate memory in a child. Either way, I'm just going to pass in env ID. I'm going to pass in a pointer to an env, and I'm going to say true. Struct env equals null. And then this is going to return 0 on success, ebad env on error. So ret if ret is less than 0, and I messed up. And if ret less than 0, ebad env return e bad env. I could technically just return ret here, because this thing actually returns ebad env anyway. But then we just kind of rely on this thing to not change. Like if this thing ever changes, then we silently might not meet the contract of up our function. So I'm just going to keep it like this. So we'll look up the environment, and then last thing we do is we page insert into the environment's page dir with a page info to pass, a VA, and maybe a perm. Maybe we just pass the perm directly, and this returns an int 0 on success e no mem. To if ret2 less than 0, well, kind of assuming, if I did return enomem here, that's kind of assuming what the return code is. So it's always one of those things. I think what I'll do, so I'll do if return to is equal to e no mem return e no mem. Else if go to inval. That's like, I don't know, that's a little bit weird. It's a little bit defensive somehow in case this thing ever changes and gets more error codes added to it. Because we want to return enomem if, only if this thing returned enomem. If returned a different error code, we just want to say invalid probably. And if it was successful, we don't fail. One could argue the same thing here, that I should be applying the same defensive principles up here actually, but it's a little bit verbose to do that. I don't totally love that. I would be inclined to say, okay, yeah, maybe rather than doing this defensive stuff, the posture is that if later whoever is changing page insert and adding a new return error code, it's their responsibility to go through and check all the callers to make sure that that things are being handled correctly, basically. So I think I would prefer to do that rather than having all this verbosity, in which case enomem. Okay. Page insert, because that's the only right, that's the failure is enomem or 0. So right. Oops. Okay. I don't know, return 0. So return 0 on success, less than 0 on error. Errors are so and so and so. I might just, just for whatever, I'm willing to do a no mem label, no mem. And for all of these places, I'll just is that really it? It's just the 2. I guess it's just the 2. Whatever. I'm going to go to no mem. So inval, no mem, bad env, whatever. Finding me out I also have the same influence when it comes to error handling. Yeah, error handling, I feel like it's a little bit of a art as well as a science. There's always trade-offs with the error handling. I don't really claim to be an expert about that, especially for like idiomatic C error handling. I wouldn't really say I know that super well. But okay. And then yeah, so my code is super buggy, and I'm so lucky that there's this comment that warns me. Now time to think through a bit more of this. So if page insert fails, we need to free the page info, right? That's actually a really common source of bugs in C programming, where you do a bunch of stuff and in your error handlers you need to make sure to undo any of these like semi-persistent changes that may have happened, like allocating memory or something. Otherwise you have leaks and stuff like that. And so you actually for every one of these, you know, honestly this thing should be way earlier. This thing should happen before we do any system activity, basically. We do all our error handling in a single place. VA, perm, envid, and then we're ready to actually take action and do things in the system. And this movement allows us to not have to do like this free thing, because for every error handling case after this, we need to make sure to free it. And now we've reduced that number to just 1. Okay, page insert. So now we're freeing the thing, that's good. And then we go to nomen. Alternatively, the page free could be in here, but maybe that's kind of weird, so I'm not going to do that. Yeah. Set to 0. Okay, the page. PTE syscall. Wait, what? What's PTE syscall? Did I miss something kind of important or would be useful? Oh, that's it. Oh, okay. I did not see this very helpful bit mask of all of the allowed bits, which is this. So PT syscall, and this is a good test. Let's see if the tests still pass with this change. They should totally pass. Right. Okay, so that's actually a change I'm going to amend in. So this, okay, so this gets amended into, oh, I mean, it's just amended into the previous one. Nice and easy. Yeah. This is just show. It's really nice to have these comments here and not be doing this all from scratch, because it does help. It definitely helps me save some work. Well, I spent the work already, but it's useful to just, especially as mostly these error handling hints. So I'm handling that now. Most of the new code you write should be to check the parameters for correctness. True. That's like 90% of this function is handling error codes. The thing I'm not sure about is if a page is already mapped to VA, that page is unmapped as a side effect. That is the remaining open question here. What happens if a page is already mapped at VA? That's going to be in page insert. So let's examine that. What happens if we try to page insert into a VA that is already mapped? If a page was already there and it was different from the given one, free it. Page info only handles a single page. So, okay. And it was different from the given one. So this seems to handle it gracefully, actually. It first takes the VA, does a query, and see if there was any mapping, any physical memory mapped to that VA. And then we check if that exists, and it was different. Yeah, if it exists, if there was a thing there, and it's different from what we're passing in, we apparently just automatically just handle that case and automatically implement the overwrite semantics. This clears the PTE, so it must be before we set it below. Okay, page remove. Yeah, wait, what's the difference between page remove and page free? Because I kind of guessed at that. Nope, page free. Return a page to the free. I think that's actually not what I want. I think I want page remove. Almost certainly, I think. Where unmaps the physical page. If there's no physical page, do nothing. Yep, okay, so that's gonna be page remove. And then this thing calls page jagcraft, which calls page free. That's confusing. Okay. Is there something wrong here? Too few arguments to function call. Wait. No, never mind. I actually had it right. Here we are just simply freeing this thing at the page allocator level. Yeah, page remove operates at the virtual memory level, actually, which is not what we're concerned with here. We're just simply interested in freeing the little thing that we just like kind of allocated for no reason. Good, okay. So that, oops, no, okay. So that should build at least. And I'm just gonna quickly check Twitter to make sure my tweet went out about this. And it did. Cool. So yeah, I think it's time for a commit. Yeah, this is all just like junk. I think it's time for a commit. I also kind of feel tempted to write some tests for this now that we have our fancy unit testing functions. What would the test do? We would need to somehow well, like the unfortunate thing is that this is the running of the tests impacts the system state even after the tests finish, which is the major downside of just running your unit tests in the init process of the actual program. Ideally, you have your main program and then a separate like test program. In this case, I guess it would be something like the main kernel and then kind of like a separate test kernel that just like boots up, runs the kernel tests, and that's it. I guess that's what that would look like, which would be kind of cool. Otherwise, if you don't have that and you still want to do tests, but you don't want to just run them at the start of the program, then you need to write all your code to be like abstracted away from the hardware and stuff, so we can compile the unit tests for it to run on my host system, which is that would be nice, but that also would be kind of challenging and not the easiest thing to do, and also probably not possible for absolutely every case. I'm just even thinking if I could do this easily. I guess I could. Let's try it. Let's try it. I'm going to drag this over here, and we're going to go and have a function that's called test sys page alloc. It's definitely pretty annoying that for any function we want to add here, we then need to export it in the header file and then adjust. No, I think maybe a nicer thing would be something called just like test syscall. This thing calls test has valid perms, which can become static, and then what? I think I added the header. I added this in the wrong place actually. That actually should have gone in this thing. I'll just put, so this goes here, test syscall, and now we're going to tests.c test syscall, and then now we don't need to worry about that. This is going to be the thing that runs all of the various syscall tests we might have. Currently it's just one, but we're about to add a second, maybe. Let me just okay, this okay, so this thing I guess should probably go at the bottom of the file, so we don't have to have these ordering things to be worried about. Okay, so now this works. So let's so this, we have our production code, we have this thing, and this is kind of new. Like I said, we will probably end up squashing this stuff later, but I'm just going to I don't know. So now that's the test. This thing. So that's this thing, and this just uses. So that looks about right. Okay. That sounds complex. Yeah. Okay, so cool. So now that we did that though, we can I don't know, we can try to write a test for this thing at a higher level. This thing was just ultra isolated. Now this thing will also be static. And the easiest thing to do is env_id. env_id cur_env_id equals. Oh wait, no. These are actually in. It's just the env_id field. So we can just, that's easy. I might still just break that out to make it less noisy. Let's cur_env_id ID, and then let's just do some crazy stuff. Let's just and we're just gonna make sure inval, for example, it's EU P. Int min perms. Okay. So min perms is like a minimum valid set of perms, and let's just make the test fail. Doesn't even compile. Ooh, that's because this thing is above, which is annoying. So time to bring it down. Pass. Makes pointer from integer without cast. Wait, no. Utop. Here's the cast. And that we need to actually remember to run this thing. That is why. Now the thing fails. Okay, good. And then now we can see it succeed. But okay. But now the tests succeed. Good. Okay, and yeah, we could, we're kind of testing this at a different level now. Top minus page size, or what is it? Page size? And we could do, so this, so I'm just going to open it up with an actually valid. So now we're actually allocating a page right below the utop limit with valid permissions. So that should actually be passing. This should all still pass. Wow, that actually, not only does that not pass, that, ugh. That reboots the machine. I wonder why that would be. That's pretty scary. But and that's the thing. I'm not sure if it's okay, like that's from this line, right? If I uncomment this line, the reboot doesn't happen. So that's caused by doing this. It's caused by doing this, which just triggers this code, and it's either I actually have a bug in here and it's causing the reboot, like I don't know, crashing or something, or it's just like I'm trying to run the test in a weird state of the kernel. Is there even a current environment? Like, I'm running the test here, but is there even an environment? Maybe, like, maybe not. Maybe it would be interesting to see what would happen if I ran the tests here after the environments are created. It probably will. Wait, let's go on that. Wait a sec. So now, okay, now let's enable this. I actually think that's not going to change anything. I think it'll still do this reboot thing. Page font in kernel mode. Okay, so here's the difference. What happened with the reboot thing is that was actually before traps are set up or interrupts are handled. When crashes happen before that, that results in just reboots. After trap init, if we crash, at least we don't reboot. We're able to handle that. But what it kind of actually seems like is I have a crash, a kernel crash that happens. And it might be worth just a quick peek to make sure I'm not doing anything stupid. So if this, so this succeeds, which means env should have a valid thing. Page alloc is a pointer, but page insert, we check if it's a null pointer, and we just pass that. We don't dereference that. So yeah, I never have time to do this, but it would be so nice to somehow convert this into a stack trace a bit more automatically. Because all I can do to debug something like this at the moment is just try to step as close as possible. Test sys that not work? Okay. Okay, so I'm here at test sys page outlook. I'm just gonna break. Oh, we're just going. Did something? Did it immediately just page fault? Okay, what happened there? Page outlook. Does this work? That doesn't even work. What? Okay, so I think it was this. That's what crashes. It's not. Actually, wait a sec. Is cur_env null? Yeah, cur_env is null. For some reason, actually. For some strange reason, is the assertion only... Okay, the assertion fails... Okay, I'm still kind of confused. But, okay, now even here... Wait, what happens here? We should still see the crash. How is there no crash? How could there possibly be no crash? Because we are doing the dereference and using it here. Is this even running? Yeah, that's running. But anyway, there's no current environment, I think. I think that's the problem. Alright, I have not taken a break yet, so I'm going to take a 20-second break just to stand up and stretch. Be right back. Yep. I kind of get the sense that I'm just like sort of wasting time a little bit here because the whole problem is like having an env ID to work with. And we're running the tests in this kind of early state. So env create, it's like allocates an environment. But cur_env is only set here in sched yield. And we can't just like run our unit tests there. So now we're just getting into some difficulties with even trying to unit test this. I guess in order to do that, we would need to kind of like set up some kind of functional, semi-functional user space with a few processes. But then kind of like stop things and then just run a kernel task, run some kind of kernel thread or something that is just kind of free to manipulate the system. And yeah, run the tests against this system. Oof is right. Oof, big oof. So I don't know, what should I do here? I could give up on writing the test, and I could just move on and not even test this code. I mean, there's not that much to test because it's all error handling, and I've kind of tested the error handling already, but it would have been kind of cool. Well, I guess really, I was also idly thinking that with this whole testing infrastructure, there should really be some kind of define or something that enables and disables the test. It's like you enable some kind of like define, and that builds the kernel in run tests mode, but then when you're running in production, you disable that define. And I don't, oh, what's it? So we already, wait a sec, we already have this test thing, but that's for these grading scripts. I would actually be interested, where is this, what's this test thing? D-test. So that's, apparently that's how it works. So you can just do -d stuff, and then from the C code, you can access that. You can kind of access that, I think. So I could do something like make a unit test target in the make file that passes -d unit test on or something, and then check for that in the C code. Okay. I think for the moment I'm going to yeah, I think I'm just going to not bother and debug stuff later if I need to. I'm just going to move on, I think. Yeah, it compiles a different kernel in like a different mode that enables and runs all the tests, and it solves the problem of having like the tests affect, like when you're like running the kernel for real, you've previously run the tests which have like allocated memory and done stuff, and those tests probably haven't cleaned themselves up so perfectly, and so they've tainted the state of the system. And so you don't really want to run in production like this kind of tainted system that like has all these side effects from the unit tests that ran previously. But I guess one thing that does make sense is to move this after. In general, I don't want to be running code before interrupts are enabled, because it's they just reboot the machine if there are bugs. So now we do that a bit earlier. Okay. So now, okay, let's get back so run tests to delete that. I'm going to amend this also there. I'm going to delete my comment here. Yeah, I mean, so there's this temp comment, there's this add infra, which I'll probably move down. You know what? I might move that down even farther. Okay, move that before we start doing stuff. Okay, then we have this temp commit, and then this whole thing. I think, you know, I think all this stuff I'm just going to squash. This also gets amended into here, and this thing gets reworded to impulses page alloc. Right? Good. Okay. So now let's run the kernel. Oh no, sys, okay. Test sys. So now this thing doesn't exist. So then this also gets merged into there. What about now? Please, okay. And things are running. I mean, we're not running any of the code I just wrote really, so it's still possible that it's buggy. But at the very least, I do feel kind of nice that we just have some tests for this like logical checking thing. And a place to do that. What's next? It says page map. Copy a page mapping, not the contents, from one environment's address space to another, leaving a memory sharing arrangement in place. Yeah, so this is something in support of shared memory between two processes. Let's just, yeah, I wonder how hard this is going to be. Map the page of memory at source VA in source NVIDs to dest VA with permission perm. Permission has the same restrictions as in syspage.alloc. Okay, that is great to hear, because that means I can just reuse that function that I made, which hopefully is above. Yeah, I can just totally reuse that function. That is so nice. Rather than copying and pasting it or whatever. From has the same, except, wait a sec. Oh no, it's not totally the same. Except that it also must not grant write access. It also, or is that an additional restriction? It also must not grant write access to a read-only page. Okay. Meaning that if you have a destination virtual, or a source virtual address, a source page that's not writable, on the other end, on the destination end, it should not also be made writable. So perm is the permission to give to the destination. So this one is technically, it should be technically called dest perm or something like that. I might even just do that rename permission perm. Maybe I won't. Okay. Return 0 on, okay. All the, so it's just like so much error handling. Use the third argument on page lookup to check the current permissions. Okay. Well, so what do we need to do? Check env IDs, check VAs, check perms. Needs to be valid. And what? We're only allowed to, like, they both need to be valid, and it's kind of funny that this like API is ultra flexible. It doesn't even assume that we're making a shared memory arrangement between ourselves and another process. It's like pick two processes and just share between them regardless of whether they're us or not. Yeah, okay. So I think the easier one, I mean, it's also these same restrictions. I mean, maybe I could isolate that out. I could make something along the lines of bool as valid VA. Perm, int perm, constant perm, or no. And it's just something like return yeah. You know, easiest thing to do is just do the not, which is a bit more complicated than I would like. Also, it's possible just to do return VA is less than and equals, right? Return VA is less than utop. I kind of wonder about, okay, yeah. And, okay, has valid VA, and need a semicolon. So now I can do if not has valid VA, and I'm just going to run that with the tests. Oh. Oops, void. Oh, wow. There we go. So that notably ran the tests. Okay. So now I can actually go ahead and I'm going to stash those two, and I'm going to amend them into the original commit. So now over here, the VAs are super. If has valid VA source VA or not has valid VA dest VA. Okay. I'll give this a little like X to say that I am doing it. Okay. And then, so the VAs are super easy to validate. The perms are likewise. So it has valid perms. Perm. Turn inval. Although, wait a second, it's not quite so simple. Perm must also not grant write access to a read-only page. So that's, in order to, so check perm doesn't give write access to read-only page. Okay, that can only happen later after we query. So this is like an initial perms check. Check env IDs, check VAs, check perms. Query source VA And after we query for it, we can then check the perm against that, and then page lookup, and then page insert. Okay. Then so we're going to look up the page in the source process, and then we're going to page insert the same page into the destination process. I'm going to do a bit of a return 0 already. Okay, check env IDs. I might just follow this same pattern of writing a function to test this, like bool has valid env ID, env ID t env ID. Okay, and the way this works is you need to have this thing, and then you do env ID to this, env ID t, and you pass in this thing, and you also, we're just going to say true for the check permission, and it returns an int. Turn has equals 0. Is that it? Is it as simple as that? Okay, and if this thing failed, it returns ebadEnv. So okay, let's go back here. So I think actually, yeah. Return ret equals 0. So that's actually it, I think, because if it's not a valid environment, this thing is going to return a bad environment. If it doesn't have the permissions to change, the caller doesn't have permissions to change one of them, it's also going to return the ebad environment. We're only actually changing the destination environment though, technically. But whatever. So it's going to be source env ID, env ID dest env ID return ebadEnv, negative ebadEnv. I don't actually know what we're eventually going to use it for, but it's for creating a shared memory mapping between two processes. And at a higher level, we're using this function and these other functions to implement a version of the fork system call, but entirely within user space. And for example, I think one use case that we might use it for is to, well, I guess we don't have a libc, but if we had a libc and we wanted to implement our fork in user space, we're going to take a process, fork it, and then we need to make sure that the libc, that libc is shared. We don't need to, but we will probably want to. to avoid duplicating memory for all these libcs everywhere. So that is a basic guess, but I don't really know yet how we're going to use this. Yeah. So we validate the VA, which is easy. The perms, which also easy. Validate the env ID. This VA is not mapped. This is so nice. It gives us all of these error conditions already. So, and it kind of corresponds to what I kind of have sketched down here, actually. But it's going to be basically the same thing, like a very, very similar thing. Actually, I guess the one unfortunate part about doing this like this is that we don't automatically get the env pointers anymore. So maybe maybe I will actually do it differently in practice. Maybe I will do source env, dest env, source env ID, source env 2, and if ret 0 or ret 2 equals 0, turn e ret env. Something like this. That would be the more inlined way to do it. Ever so slightly more efficient because we don't need to call env ID twice. Yeah, and if we did it in the top way, we would first have these, and then we could just call it. We would basically have exactly this code, these 4 lines exactly. We could just then assert that return is equal to 0 in both cases. I kind of have the suspicion that it's not worth it to do that, so I'm going to not do that. So now we have this. So they're valid. And now we're going to do a page lookup. Page info, page lookup with the source env page dir at source VA and 20-second break. Be right back. Okay, and then what? And then PTE store, okay. So PTE, and we need to declare a PTE PTE. I don't know, equals 0 or something. Just to make sure. Yeah. Is that right? It's just a single pointer. It's a double pointer to a PTE store. Okay. pointing to a PTE, info, and I always forget, what's the deal with this? Return null if there's no page mapped. Right. Val. If source VA is not mapped and source env ID's address space. Okay, is the perm appropriate? So now we need to check if perm and PTE right, and perm is that, and PTE right, and okay. If the destination permissions, if we're basically trying to map into the process and have it be writable on the other end of the destination, but the PTE on the source end is not writable, we don't want that. I think that's right, yeah. Okay, and then lastly, page insert. Insert into dest env page dir page info dest va perm. And we need to be ultra careful. Wait a sec. No, I was gonna say we need to be ultra careful to free any allocations we did, but we did not actually make any allocations, so that is fine. And then the ret here is just the mem ret. Query source via page, right. Nice. Have no idea if this code runs correctly, but okay. We have all these rets. I actually am not. What's the best convention for this? So now I would make a ret 3. You know what? I'm gonna ask ChatGPT what it thinks about this. Expert C programmer. Have this code snippet where I have all these ret variables for error handling. Seems messy to use ret 2, ret 3. What's your opinion on the most idiomatic solution here? You're right, using this KMSE would involve, we're using a single ret variable. Exiting earlier on. That is true. I could reassign it. That is the obvious solution. I can't, I mean, oh wait, also what the, exiting early on doesn't help. Okay. That is true. Yeah, that is kind of dumb that I even had to ask. But yeah, the reason I didn't immediately do that is I like to avoid mutating variables if I can, and I would prefer to make these things const. Which is why I kind of default to making just new ones for everything. But there's the big downside of that, because like there's this maintainability downside where if I start naming them ret2, ret3, and then I go back and refactor this away later, and I forget, then I need to like update all these rets to make sure the naming is still sensical, which is not good for maintainability. So I think in this case, yeah, probably using the mutable return is right. Okay, but actually here I actually genuinely do. Well, not really. No, I don't really. Yeah, I can just do 2 calls, which is a little bit verbose, but whatever. I have my ret, and I just try various times, and I try once more. Yeah, error could also work as the name, except then at the very end. Well, yeah, I guess we don't need to return the ret variable, but I'm not sure I would name it error necessarily, because it's not necessarily an error. It's not like it's always an error. Sometimes it's an actual success condition, but maybe error stands for error code. Yeah, I don't know. I guess, yeah, I often use ret actually for it to hold the variable that the function ultimately returns, which I'm not doing in this case. This is just to hold the intermediate return codes. Actually, no, that's a good point. Maybe ret is not a good name, because I'm not actually returning this value. It might seem like I am. You know what? I'm actually a little bit convinced. I might change it to error. I think it's, yeah, usually I use the ret if we're ultimately going to return something, but we're not doing that. How does error look? Oops, shit. I have to say, I like that better. I do like that better. I'm gonna go with it. Thanks, Ismail. I'm gonna go with that one. Let's see. Does it compile? Good. And that pretty much brings us out to the end of our time. This unmap page. Quick peek at what the next one looks like. Page unmap. No, I remain open to being convinced. Definitely, absolutely. Okay, unmapped memory in the address space of NYD. Okay, this thing I guess is going to be super easy. Okay, and I'm so experienced at writing this kind of like boilerplate code already that I'm going to power through this. Wow, turn 0 to error. The new fancy int error, nvid2, env id, env true. No page is mapped. It silently succeeds if error is less than 0. return. Okay. If now it has valid va return inval. Man, it's one of those streams where I just write a ton of code and don't run any of it and just hope that this is going to work. And yeah, it's all just this nice, easy boilerplate to write. Bad M doesn't have permission. Change inv ID. And then what? Int error equals page remove. Page dir va. Okay. There is no error handling. Okay, it just returns. So there's no threads. Okay. Under the memory of VA in the address space. If no page is mapped, what would happen? If no page is mapped, it silently succeeds, and that we just get that for free because this thing silently succeeds. Actually, I didn't commit anything yet, so I'm gonna get rid of all this. I'm gonna get rid of this, which I'm not using. This is this page map, which I was just doing. So pull sys page map, and then last stuff is here. And pull sys page unmap. I could technically make this const. Yeah. Okay. And let's see, I think that will, implement, okay, I mean, it did it. Make sure syscall calls them. I did not do that, but I kind of want to just see if this works. XO, okay. So here it's going to be something like sys page alloc. Which takes 3 arguments, A1, A2, A3, and returns something, okay. And then we're gonna do page map. This is page map, and that's going to be 5 arguments. Do I even have room for 5 arguments? That maxes out the number of arguments. And page unmap. Page unmap, and that has 2 arguments. And does that even return something? Yeah, I think they all did, right? Oh. Yo, what's up, average Debian tester enjoyer? Thanks for joining. Okay. All these errors about me not, what is it? It's So these are all what? These are all integers? Okay. So this needs to be a pointer. What about over here? The second one and the fourth one are pointers. Okay. Okay. Doing pretty well, actually. This is a very productive stream. Might be ending it kind of soon, actually, but it was super productive. We implemented all these system calls that will eventually let us fork a process or something like that. This is page unmap. Yeah. Okay. Oh no. Void. Okay. Does it build? It builds. I mean, you use these various functions, blah, blah, blah. Should we do it? Should we try to run it? I think I did everything. We can just run this thing, I think. I just run dumb fork. Uses the above to create and run a child environment with a copy of its own address space. The two environments switch back and forth using sysyield. Okay, this is probably not going to work. And in either case, I'm going to end the stream. But we'll end on this massive moment of truth where it probably doesn't work. Just as a quick look through, what does dumb fork do? So main, it calls dumb fork, which is what implemented right here. And okay, it basically forks the process, and then the rest of main continues to run in both the parent and the child, and it just runs this loop where they just yield for 10 or 20 times depending on that. And here it is. Here's the user space implementation of fork based on the system calls we just wrote. We exo fork. Exo fork in panic. If we're the child, the copied value, we have to patch up our memory layout because there's like this variable. This fork create a copy memory mapping, or does it behave like it does? It definitely does not do copy on write because we haven't done that yet. This is like the very basic version of it, but actually we do support shared memory. So it doesn't copy the pages. It creates, I mean, yeah, I guess it creates shared references, and then we just don't have cow support yet because we haven't gotten there yet. But okay, so we exo fork, we patch up our memory, and then in that case we just return. Otherwise, we're the parent, eagerly copy our entire address space into the child. Oh, okay, so dupe page. Yeah, this is literally actually copying like all of the memory. Okay, so it seems to not actually be using all of these system calls. Or no, wait, no, page map. It actually is, never mind. But it seems incomplete. It seems like we will need to do things. I'll also copy the stack. Copy it into the child. What's up, Karan? Yeah, totally. I mean, I'm just gonna link you to my resources, which I've explained a bit about this, or just have some resources. I mean, the quick answer is these days I'm recommending Harvard CS61 as the class if you want to get into this stuff. That class has, like, it seems to be a great foundation for like systems programming in C, and it also has some kernel development exercises. Also, okay, I don't totally get. I don't totally get this. We're copying them into the child? How is that safe to do? Because isn't the child concurrently running? Or maybe not, because we haven't yielded yet. So I don't know. I have a lot of questions, but start the child. Ah, okay, yeah, we explicitly set it to runnable. I forgot about that. So we can fork, and we don't have to worry about race conditions because the child doesn't immediately start running concurrently. It waits to be explicitly started. So we can do all sorts of stuff and muck with its memory and whatever. Yeah, and then we start it. All right, moment of truth. 3, or is it ready? Okay, dumb fork. Let's comment out the run tests, and let's watch this thing crash. I'm just gonna do 1 CPU just to start. Okay, it didn't crash, but the parent never ran. It didn't crash, but the parent never ran. Yeah, we should. We should have seen the parent run, but at least it didn't crash. 2 CPUs? How's the macOS? We're doing low-level dev. Are you running Linux VM in the background? It's pretty decent. I am not running a Linux VM. Like, there's no Linux involved here. I'm developing the source. I'm editing the source files on macOS, and I'm running my kernel in QEMU. So I'm using an emulator, certainly. But so far, I'm having a pretty decent time. Yeah, it's not so bad. Okay, well, it would seem like the parent never ran. Why would that be? Okay, so I don't know. I don't know if I feel like debugging this. So yeah, I'm not gonna do that. I'm gonna do that next time. So yeah, with that, I'm gonna bring the stream to a close. Oh man, so many people joined. Man, so many people joined in like the last like 15 minutes. That's too bad. Well, thanks for joining. I need to leave now, but I do this every week. Feel free to come back. It's every week at the same time on Sunday. I'm gonna link to my Discord. Please subscribe to my channel. If you like what I'm doing, please like or leave a comment or something. If you dig what I'm up to, yeah. And hopefully I'll see you next week for all the new people that just joined. And shout out for Ismail for hanging out and also giving me a lot of tips and help with the error message, error variable name. All right, have a nice week, and I will see you next time. Peace. Cheers.